So the third video for 8D notes, we're going to do example 5. It says find a third degree equation with integral coefficients that has 3 and 2 plus I as roots. So we learned that if 3 is a root, then we know that x plus, or not x plus, x minus 3 is a factor. And if 2 plus I is a root, we also know that 2 minus I is also a root. So I have x minus the 3, then I'm going to have x, and I'll make that really dark again, minus, and then it's going to be 2 plus I, so 2 plus I, so it's going to be x minus 2 plus I, and then x minus, and then this other root of 2 minus I. So it looks like this. So I'm going to get rid of these inside parentheses and distribute. So I have x minus 3 times x minus 2 minus I, and then x minus 2 plus I. Don't forget to distribute that minus in right there. So what I want to do now is I need to multiply this out to get that third degree equation. We're not going to leave it in factored form. We're going to put it in the standard form. And what you're going to find is that it's going to be best to go ahead and multiply your imaginary roots together first. Now I'm going to choose to use a box method on this. So I'm going to put this, I'll put it over here to the side, x minus 2 plus I, and we'll make a box here for that. And then over here we're going to put the middle one, so x minus 2 minus I. So x minus 2 minus I. So I'm going to then multiply x times x and get x squared. X times negative 2, that's negative 2x. And this is I times x right there. Then negative 2 times x, negative 2 times negative 2, that's 4. And then negative 2i. The negative I times x, so negative ix. And a positive 2i, and then a negative I squared. All right, so now what you're going to notice is that we're going to have, here I have an ix and a negative ix, so those are going to make a 0. Then we have a negative 2i and a positive 2i, so that also makes 0. So what we have left here then is going to be x squared. So this is going to be x squared. Have a negative 2x and a negative 2x. That's minus 4x. And now I have the 4 and the negative I squared. So remember that the negative I squared becomes, I squared, remember, is a negative 1. So this is a negative 1, which makes a positive 1 right there. So then I'm going to have 4 plus 1. So that's going to give me a plus 5 here, right there in that spot. So now I have x minus 3 times this. And again, I'm going to double distribute. So x times each one of these and negative 3 times each one of these. So again, you could use a box if you want to. I can probably do this one a little easier in my head. So I'm going to do x to the third minus 4x squared, and then plus 5x. Then I have a minus 3x squared, plus 12x, and a minus 15. So we'll add those together, and we get x to the third minus 7x squared, plus 17x, minus 15. And here is my third degree polynomial with these roots that go to it. All right, so I believe it's time now to stop that video and give this a try on that next spot. So this time you'll be finding a second degree polynomial with roots of 2 plus 3i. So give it a try. It may not be easy, but at least give it a try and see what you get. So stop that video before we go to the next one. All right, so then example 6, it says find a fourth degree polynomial with integral coefficients that has zeros of a negative 4i and a negative 3i. So because we know that our imaginary answers or solutions come in conjugate pairs, the conjugate of negative 4i is positive 4i, and the conjugate of negative 3i is a positive 3i. So I have now the 1, 2, 3, 4 roots, and that's going to give me a fourth degree polynomial when I multiply all my factors out. So that's going to give me then x minus and minus gives me x plus 4i, and I'm going to put its conjugate next to it. So that's x minus 4i. And then here, x minus a minus gives me x plus 3i, and then x minus 3i. And we want to multiply this out. So you might want to use a box to do it. Let's see, let's just do that. So I can kind of demonstrate it. So x and 4i. And then here we're going to have x minus 4i. So we will get then x squared. We'll get a minus 4ix and a plus 4ix right here. And then 4i times negative 4i is going to be a negative 16i squared. And of course this then is going to be equal to a plus 16 for that right there. All right, so then we'll come over and do our 3i's. So I get x and I get a 3i. And then on top we have x minus 3i. And that will give us x squared minus 3ix plus 3ix, and then minus 9i squared, which is going to give us a plus 9. All right, so as in the last problem, you see that the i's will, when you're multiplying by those conjugates, have a negative 4ix and a positive, so that's a 0. So here I'm going to have x squared plus 16. So here we have x squared plus 16. And over here, the same situation. And I'm going to have x squared plus 9. So now I want to multiply this out. So I'm going to get x squared times x squared, that's x to the 4th. I have a plus 9x squared and a plus 16x squared is plus 25x squared, and then 16 times 9 is 144. All right, so go ahead and try this last one here and see how you do. We can check that out next class, and that's it.